3.2 States of Matter. Key ideas from this section: what happens when a substance changes from one state of matter to another, and what happens to mass and energy during physical and chemical changes. So, the identity of a substance doesn't change during a change of state, but the energy of a substance does. So, states of matter we talked about the other day are solids, liquids, gases, plasma. On Earth, we really focus on solids, liquids, gases. So, when something changes from a solid to a liquid or a liquid to a gas, the identity of the substance, the things that it's made of, doesn't change, but the amount of energy of the particles of that substance does. So this is a diagram just showing the names of the changes. And so going from a solid to a gas is called sublimation. Gas to a liquid is condensation. Liquid to a solid is freezing. Then going back, solid to liquid is melting. Liquid to gas is evaporation. You do need to know what each of those names are. Also notice that some are red arrows and some are blue. Red arrows means that you have to add heat or energy into it to get that change to occur. The blue arrows means it needs to cool down or take heat away to get that change to occur. And so just like those arrows, some were blue, some were red, some changes of state require the addition of energy or require heat. The changes of state that require heat are called melting, evaporation, and sublimation. Evaporation is changing from a liquid to a gas. Sublimation is going from a solid directly to a gas, skipping that liquid phase. And then melting isn't on here, but it is going from a solid to a liquid. And in some changes of state, energy is released. And so that would be your blue arrows on that diagram. Changes of state that release energy are called freezing and condensation. Freezing is going from a liquid to a solid, and then condensation is going from a gas straight to going from a gas to a liquid. So this is a diagram that you may encounter maybe on like the ACT. You might see these, but it is a state or a phase change graph for water for this one, but you may see it in other places for other substances. And so what this is showing is that in the blue area, so from negative 20 degrees up to 0, this is a solid, and so for water we call it ice. Then from the green arrow, from 0 to 100 degrees Celsius, it's a liquid, and we call it water. And then in the red or orangish color from 100 up is a gas, and we call that steam. And we're talking about water. So as you go up, this is showing the amount of energy. This line is the amount of energy that is being added. And then as the line is moving up, it's adding energy. And as the line is moving over, the temperature is increasing. So at number 1, it says energy is released when water freezes and is absorbed when ice melts. Notice that there's an area where it just jumps straight up, and so energy is being added, but the temperature is not increasing. Again, at this line where the liquid and gas phase meet, the line is just jumping straight up, and the temperature is not changing. So it means energy is being added or released, but the temperature is not changing. And so what happens when you have a change of state? So when you're melting, freezing, condensation, evaporation, whatever, when you get to the temperature that would occur, then heat is being added or released, energy is being added or released, and the temperature doesn't increase until the entire amount of that substance is changed over. So if I have a pot of boiling water, it's going to stay at 100 degrees Celsius until all of that liquid water is changed over to a gas. And then once all of that is changed to a gas, then that steam can increase its temperature. So mass and energy are both conserved, which means that we don't lose them. Neither mass nor energy can be created or destroyed. Mass cannot be created or destroyed. In a chemical change as well as in physical changes, the total mass of substances undergoing the change stays the same before and after the change. For example, if I am melting ice, the ice is going to be a certain mass. As that ice melts, I should end up with the same exact mass of liquid water. If I am boiling water, then I start out with a certain mass of liquid. After that all evaporates, I should have the same exact mass of steam particles. And this is called the law of conservation of mass. If I burn something like paper, it looks like the thing that matter has been destroyed, but if I collect all the gases, all the smoke, and all the stuff that the ashes and the smoke from the burning paper, I should still have the same amount of mass before and after the reaction. Same thing with energy. Energy cannot be created or destroyed, but it may be changed to another form during a physical or chemical change. So it can change forms, but the total amount of energy present before and after the change stays the same. So if I have energy, so much energy before, I'm going to have that same amount of energy after. It just might be in a different form. So it might be from the form of energy, chemical energy in the wood, to change into light and heat energy from a fire. And this is called the law of conservation of energy.